The first set of tools that I want to show you are the GNU binutils. These are a collection of tools, and I won't cover all of them, but just a specific subset that I find helpful. And here I want to start with the command strings, which you may already know from Windows. Strings should be included in any mainstream Linux distribution. So if you just type strings and then give it a file and run it on that, you get the familiar output from Windows. And as you can see here, there's already an IP address in here. This program com is a little program that I wrote. But as you may know, strings is just very useful to extract information. One other command line utility that is not part of binutils, but I want to show you nevertheless, is called file. With file, you can examine a binary and get more information about it. Actually, you can examine any file with the file command, and I'm just gonna run this on the COM program. And here you can see it's an ELF 64-bit. ELF is the executable linkable format, the format for executables on Linux. In addition to this information, it also shows you the target architecture. And ignoring this middle part for now, it shows you here not stripped. And we will talk about stripping binaries in a moment. That being said, the file command is very useful, and I regularly use the file command to check malware samples that I download. The command readoff is part of binutils again, and if I run this on a binary that is not stripped, in our example that's COM, with the option all, you can see you get a huge amount of information here. Let's start right at the beginning. You're presented with the ELF header. Here you can also find the target architecture in the machine parameter. Then, for instance, the class shows you it's an ELF 64. Then here is information about the section headers. You can get more information about these down here. For example, here you can see the text section. If we come down, there's program header information, and so on and so forth. I don't want to cover the ELF format in detail here, so I'm just going to skip over it. But nevertheless, this is a very useful command. For example, let me just stay here for a second. Here is the symbol table, and this contains function names if the binary is not stripped. For instance, here you can see that there's the function getSockName, there's the function connect and socket host to network short. So this may imply that the binary is used to perform some sort of a network communication. readoff is pretty useful when it comes to finding out if something strange is going on with the binary. Here I took my COM program and packed it with UPX. If I now run readelf with the all option on it, we can see the output is much shorter. And here in the ELF header output, we can see that the number of section headers is now 0. Next, let's have a look at the command strip, which is also part of binutils and is used to discard symbols, aka strip a binary. If you want more information about any Linux command, you can just enter man for manual pages, and then the command you want more information about. This leads you to a nice description of the command and all of its parameters. For instance, here for strip, there is this strip all option here, which we are going to use in a second. And you also get some kind of a general description about the command, where here it says, okay, GNU strip discards all symbols from an object file. Let's try this out. First, we are going to compile my little program with GCC and the static option to statically compile. Then we're going to apply it to the program, and the output is going to be called LRE 00 stripped. Now we will use the strip all command and strip the binary. In order to look at the effect that strip has, we are going to use the last tool out of binutils that I want to show you in this video, and that is the tool object dump. With object dump, you can disassemble a object file. Of course, you can do loads more, but here I just want to concentrate on this disassembly option. If you want to know more about object dump, you can consult the manual pages. I'm going to give it the option uppercase M and give it Intel to get the Intel syntax for disassembly. And with -D, I give it the disassembly option and apply this to LRE 00. And this is the binary that I compiled that is not stripped. If I do object dump here, you can see all of these functions, but what I am interested in is the main function, and here you can see that a function called XOR crypt is called, which is disassembled down here. Now let's do an object dump of the strip binary. Because the strip binary is statically compiled, there is a lot more code inside of it. That is why I wrote the output of object dump to a text file that I opened in my editor here, and I located the main function manually. As you can see here, the same constants here are moved to RAX and RDX. So we are indeed located in the main, but the symbol for the main is gone. That is one effect of stripping. Now, there's only one function call in the main, and this is the call to XOR crypt. This symbol for XOR crypt is also gone. So instead of the symbol, you just get a call and then this hexadecimal address. We know that XOR crypt is located right below the main. That means if we just come here, you can see that this is the function that is called XOR crypt. And you can also determine this by just looking at this line where the XOR is applied to ECX with this constant hexadecimal 3b, which would be here. So this is an effect of stripping, that all of these function names are gone. This does not only apply to functions that you wrote yourself, but also to any library functions or system calls. Needless to say, stripping a binary makes analysis harder, but there are ways to make your life easier, which I will also show you in a future video. That brings me to the end of this video. And just to summarize real quick, we talked about the file command, which you can use on any file. For example, here on the left side, I have an unknown file called X. If I run file on it, I can identify it as a tar archive. We saw readoff, which is specifically meant to be used on ELF binaries to extract information. And as we saw, we found out quite a lot about an ELF file using the readoff command. Of course, there was strings, just to extract any strings from an object file that might be human readable. And we saw the strip command and its effect by using the object dump command. And in future videos, we will have a closer look at stripped binaries and some tips and tricks for their analysis. With that being said, if you made it this far, I thank you very much for watching, and I will see you around. Goodbye.